Hi, this is my explanation for problem number 1 from problem set number 9. So this question is asking, so find a closed formula for the following sequence of integers, and here are the different sequences, so A, B, C, D. So starting with A, 4, 5, 7, 11, 19, and 35. So I brought the sequence down here and rewrote it, and then I started to check and see if there was any type of pattern I could see between the differences of the integers. So what I'm seeing here is that between 4 and 5, there's 1. Between 5 and 7, there's 2. Between 7 and 11, there's 4. Between 11 and 19, 8. And 19 and 35, there's 16. So the pattern that I saw here was that this is 2 to the n difference between them. So essentially, I was able to figure out that this is an important part of the equation, and starting at n0 equals 4, um, we can start with the first term being the difference of 2 to the, or 2 to the 0. So 2 to the 0 would have been 1 plus 3 equals 4. So that gets us our first term. And we come up with the general formula of n equals 3 plus 2 to the n. Moving on to the second one, we have 0, 3, 8, 15, 24, 35, up to n0 equals 0. Or, sorry, and then continuing. So between the first two, I saw that 3 is the difference. Between 3 and 8, 5. Between 8 and 15, 7. 15 and 24, the difference is 9. And 24 and 35, the difference is 11. So here I found a pattern of increasing odd integers between the numbers, starting with 3. Um, so I kind of just started with the first term n0 equaling 0, and then started to build up some of the next sequential terms. So I believe this is n2, n2 I started at, and n3. Um, so I got a general formula of n equals n times n plus 2, this pattern. So for C, we had 6, 12, 20, 30, and 42. Difference between 6 and 12 is 6, 12 and 28, 20 and 30, 10, 30 and 42, 12. And so there's really not much of a discernible pattern between those numbers. However, the difference of the differences is 2. So you can see that that is going to be this summation formula that we have written in our notes. And again, starting with the basic numbers, I was able to find, so from n0, 6, and 1 is 12, and a general pattern and formula is n equals n times m plus 1, and that satisfies for all of these terms. So then finally for D, we got 0, 2, 7, 15, 26, 40, and 57. So again, the difference between 0 and 2 is 2, 2 and 7 is 5, 8. The next one, 11, 14, and 17. And this had a kind of similar pattern where the difference between the differences is 3. Um, so it was very similar to the one above, where that is part of the equation, except we're increasing by a different amount of the differences. So for this equation, we came up with n as a general formula, n times 3n plus 1 over n. And that continues on and satisfies all of the other terms. Thank you.